Welcome to today's lesson. We are going to look at problem solving, and in here we are going to apply the formulas of calculating centripetal force. So we start with the first example. We have a car travels over a humpback bridge of radius of curvature 40 meters. Calculate maximum speed of the car if its wheels are to stay in contact with the bridge. Take G as 10 meters per second squared. This is the diagram that we have here. The car is at that particular point. Now, to get to the value of the maximum speed, we consider this expression. This is centripetal force, which is given by mg minus r. These two, if you look at them, they are acting in opposite direction. But r, for us to get the maximum speed, r must be equals to 0. Therefore, mv squared over r is equals to mg. From here, we can make v squared the subject of the formula and finally get that v is equals to square root of rg. Our r is 40 meters and we have g as 10. Therefore, we are getting the square root of 400, which is 20 meters per second. Then we move to another example. We have a wooden block of mass 200 grams is placed at a distance of 9 centimeters from the center of a turntable. When the turntable is rotated at constant angular velocity, the block begins to slide off the table. If the frictional force between the block and the turntable is 1.2 Newton, determine 1, the coefficient of friction between the block and the turntable. Now, to get that, we apply this formula that the frictional force is equals to mu mg, where mu is the coefficient of friction. Substituting the values in our equation, we have 1.2 Newton is equals to mu, then we multiply by 0.2, which is our mass, multiplied by 10. And we have that our mu is equals to 1.2, which is here, then divided by this term. And when you divide that, you get it is 0.6. Then we are supposed to get the linear speed of the block. And to get that, we apply the formula of getting the centripetal force. And that centripetal force is also being provided by the friction force. Friction force is given as 1.2 Newton. So by substituting again the values in our equation here, we will have that 1.2 is equals to 0.2, which is our mass, multiplied by v squared divided by 0.09, which is the radius. Now again, you will get that v squared is equals to 1.2 times 0.09 over 0.2. Now to get v, you get the square root of this, which is 0.73 meters per second. Then part 3, if the angular velocity is increased by 2 pi rads per second, what would be the force required to hold the block at the same place? So we are increasing the angular velocity. So the first step is to calculate the initial angular velocity before the increase. And to get that, we need the linear velocity divided by r. And our linear velocity here, we've calculated that it is 0.73 divided by 0.09. You get that it is 8.11 rads per second. Then increasing the angular velocity, we are increasing by 2 pi. When you multiply 2 pi, you get that it is 6.28. When you add, you get 14.393 rads per second. This is now our new angular velocity. Therefore, to get the force, we need now to use the formula mr omega squared. We have our mass, we have our radius, and now we have the new angular velocity, which is 14.393. When you substitute those values and you multiply using your calculators, you will get that the value is 3.73 newtons. We move to another example. We have that a block of wood of mass 50 grams is placed 18 centimeters from the center of the disc that makes 2 revolutions in 1 second. Calculate the centripetal acceleration. Now, to get the centripetal acceleration, we can start by getting the angular velocity. You know, angular velocity is change in angular displacement of a change in time. And to get the angular displacement, we need the number of revolutions, then times the value of one revolution. This is 2 pi for one revolution, then times 2, and then we divide by the number of seconds. It is in 1 second, so we divide by 1. So our omega, which is our angular displacement, our angular velocity, is given by 4 pi rads per second. Therefore, our acceleration is equals to r omega squared. So we substitute 0.08 times 4 pi times 4 pi. You get that it is 12.63 meters per second squared. Then from there, we are supposed to get the frictional force between the block and the disk. To do this, we need to get the centripetal force, because frictional force is the one that is providing the centripetal force. And the centripetal force, you get it from this formula, m r omega squared. We have our m, mass, we have our radius, 0.08, and then we have our omega squared. By multiplying, you have 0.051 newtons. Then we move to another question. A block of mass is 200 grams is placed on a frictionless rotating table while fixed to the center of the table by a thin thread. The distance from the center of the table to the block is 15 centimeters. If the maximum tension the thread can withstand is 5.6 Newton, determine the maximum angular velocity the table can attain before the thread cuts. Now, to get that, we know that the tension is the one that is providing the friction, and it's the one that is providing the centripetal. So we have 5.6 Newton is equals to mass 0.2 times 0.15. 0.15 is our radius, you have it here, then times omega squared. When you multiply, you will get that this one, when you multiply, is 0.03. Therefore, we have that omega squared will be the square root of this 5.6 divided by 0.03, which is 13.63 rads per second. Then we have another question. Find the maximum speed with which a car of mass 100 kg can take a corner of radius 20 meters if the coefficient of friction between the rod and the tire is 0.5. We proceed as follows. First, we need to get the friction, because we are given the coefficient, we are given the mass, and we are given g. We always use 10 as g. So our friction force is 500 newtons. But this friction is the same as the centripetal. The friction is providing the centripetal force. Therefore, this friction is equals to mv squared over r. So we have 500, which is our friction force, is equals to 100 mass, which is this one, times v squared divided by 20, which is our radius. So to get v, you get the square root of this. That is 500. Then if you divide this will be 5. So it is 500 divided by 5, you get 100. Square root of 100, you get 10 meters per second. So that is the maximum speed that car can take that corner. Then we have another question. A bucket full of water is wheeled in a vertical circular path of radius 1.6 meters. Determine the minimum speed required to keep the water intact. Again, take G as 10 Newton per kg. Our V is given by the square root of Rg. By just substituting, our R is 1.6 and our G is 10, you get that the square root of that is 4 meters per second. So that is the minimum speed. Then another question. Determine the angular velocity of the wheels of a car of diameter 60 centimeters when the car is moving at 20 meters per second. So you are given the velocity. So you can determine the angular velocity by using this relationship, that omega is equal to this v over r. So you take v as your linear velocity, that is 20 meters per second, divided by r, which is 0.3. Remember, whatever was given here was the diameter. So when you divide, you get that it is 66.67 rads per second. Then we have another question. A certain man is trained in a centrifuge that has an arm length of 6 meters. If the man can start the acceleration of 90 meters per second squared, what is the maximum number of revolutions per second that the centrifuge can make? First of all, we are given the formula of getting the acceleration. And we are given the acceleration that man can withstand, which is 90. So 90 is equals to omega squared multiplied by 6. Our 6 is the radius. So we can be able to get that omega squared is 90 over 6. Therefore, omega is the square root of 90 over 6, which is 3.873 rads per second. But the question is asking about the number of revolutions per second. In other words, it is asking about the frequency. And we know that the frequency is given by omega over 2 pi. So you get the omega here, you divide by 2 pi, so that you get that f is 0.62 revolutions per second. Then we have a quiz, and at the end of each question, especially the calculations, there is an answer. So work and ensure that you are getting the answer that is indicated. For the statement or for the explanation, I would urge that you get the explanation from your head after reading and revising. Make sure that you are getting the answers from your head so that you can be able to retain knowledge. But for the calculations, do a lot of calculations and make sure that you practice a lot, because practice makes perfect. Thank you, and let us meet in our next topic.